Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, now we come to the application part of PDE, okay, which is solving with equation using Fourier transformation method. Okay, this is the example of with equation. We need to solve using Fourier transformation. Okay, from the question here, it's given UTT equals to 4U XX. So UTT here means delta square U over delta T square, meaning the second order. Here 4UXX mean, okay, UXX here is delta square U over delta X square. And we are given boundary condition. Okay, this is actually our boundary condition. U at 0 equals to 0. This is first boundary condition. And also we have ut at 0 equals to fx. This is second boundary condition. And given fx equals to 3 and 0 for the interval -7 to 7. Okay, the first step. Here what we need to do is, okay, step 1. Okay, take Fourier transform. Okay, remember, okay, you can look at the previous video, okay, the previous part, okay, part 1. Okay, the Fourier transform of UXT equals to UXT EI alpha x from negative infinity to infinity. Okay, this is the formula for Fourier transform of UXT. So equals to U hat alpha t. Okay, meaning when we transform the function UXT, so now it's become U hat alpha t. Okay, so Fourier transform of fx, our function is fx, equals to fx ei alpha x dx. Okay, from -2, sorry, not -2, -7 to 7. Okay, so we change fx with our function, so 3. So -7 to 7, 3 ei alpha x dx. 3 we can put outside, so 3 integral of ei alpha x dx from -7 to 7. So we integrate exponential e to the power of I alpha x, we get, so 3 outside, so ei alpha x over I alpha from -7 to 7. So we substitute x with -7 and 7. We will get 3 over I alpha ei7 alpha minus e to the power of -i7 alpha. Okay, this is our Fourier transform of fx. And this term, e to the power of i7 alpha minus e to the power of -i7 alpha, we can change it into another form from the identity. Okay, from identity, e ix minus e negative I x equals to 2I sine x. Okay, this is from identity. Okay, since we have 7 alpha, so let x equals to 7 alpha. So it's become 2I sine 7 alpha. So we can change this term into 2I 7 alpha. So equals to 3 over I alpha 2I sine 7 alpha. So here we can cancel. So 6 sine 7 alpha over alpha. So this is our Fourier transform of f(x). This is our Fourier transform of f(x). Okay, now we move to the second step. Step 2. Okay, we solve for ODE and find general solution. For u hat alpha t, meaning the Fourier transform of uxt. Okay, look at our equation. So we have utt equals to 4uxx. So we have utt equals to 4uxx. Okay, for this utt, our Fourier transform of utt equals to delta square u hat over delta t square. And this Fourier transform of uxx equals to negative alpha square u hat. Okay, this term you can get it from the Fourier transform of derivative. This is, since this is second order, so Fourier transform of second order derivative. So you will get negative alpha square u hat. Okay, you can look at from the video from previous part. Okay, so here we have u hat tt equals to negative 4 alpha square u hat. Okay, from this is the ODE. So u hat tt plus 4 alpha square u hat equals to 0. Okay, from this we can transform into auxiliary equation. So since this is second order, Okay, since this is second order, so you can put this m square plus 3 alpha square. Sorry, not 3, 4 alpha square equals to 0. So we will get m equals to plus minus 2 alpha I. Okay, so this is the complex conjugate root. Okay, normally it's in the form of alpha plus minus beta I. Okay, since here we only have plus minus to alpha I, so meaning our alpha is 0, so meaning we have 0 plus minus 2 alpha I, so our alpha is 0 and our beta is 2 alpha. Okay, so the general solution, okay, you had alpha t equals to, so the general solution for complex conjugate root is a e alpha t cos beta t plus b e alpha t sin beta t. So we have a e, our alpha is 0, so it's 0, cos 2 alpha t plus b e 0 sin 2 alpha t. So e power 0 is 1, so we have a cos 2 alpha t, b sin 2 alpha t. So this is our general solution, uxt. You had xt. Okay, then we move to third step. Step number 3. So we need to apply boundary condition. Okay, we have first boundary condition. U at 0 equals to 0. Okay, when we fully transform this, u at 0, it will become u hat alpha 0 equals to 0. So u hat alpha 0 actually is from this, meaning you had alpha, this is t. So our t we substitute with 0, so the general equation will become 0. So 0 equals to a cos 2 alpha 0 plus b sin 2 alpha 0. So meaning we have a cos 0 plus b sin 0. Cos 0 is 1, so we have a plus b sin 0 is 0. So we have a equals to 0. So we have a equals to 0. Okay, since we have a equals to 0, so our u hat alpha t become 0 plus b sin 2 alpha t. So our u hat alpha t become b sine 2 alpha t. And we have ut x0 okay, so ut xt, okay, when we make it as Fourier transform, so it's become u hat t. So actually ut here is delta u over delta square. Sorry, delta u over delta t. So u hat t meaning delta u hat over delta t. So meaning we differentiate this equation. So now it's become 2 alpha b beta, sorry, 2 alpha b, not beta, 2 alpha b cos 2 alpha t. Okay, now we apply the second boundary condition. Okay, this is our first boundary condition. This is our first boundary condition. And now we have to apply second boundary condition. Okay, we have ut x0 equals to fx. Okay, we make it as Fourier transform. We transform this by using Fourier transform. It will become ut u hat t alpha t equals to Fourier transform of fx. Okay, this u hat t alpha t actually from this. Okay, but from the boundary condition, our t is 0. Okay, since our t is 0, so u hat t alpha 0. So we have to substitute t with 0. Okay, when we substitute t with 0, so we have here actually equals to 2 alpha b cos 2 alpha t we substitute with 0. So we will get 2 alpha b. And for this part, Fourier transform of fx. Okay, Fourier transform of fx, actually, we can get from here. This is Fourier transform of fx from the step number 1. We can get this from step number 1 here. Equals to 6 sine 7 alpha over alpha. 6 sine 7 alpha over alpha. So equals to 6 sine 7 alpha over alpha. Okay, actually we can take this from step 1. Okay, you have alpha t as t equals to 0, and this is Fourier transform of fx. You can take this from step number 1. Okay, we can solve for this. So we will get b equals to 3 sine 7 alpha over alpha square. Okay, this is our b. Okay, then we can substitute b into here. We can substitute b into this. Okay. Substitute b into u hat alpha t, so equals to b sine 2 alpha t, sine 2 alpha t. So we substitute b with his, substitute b to this, so it's become 3 sine 7 alpha over alpha square sine 2 alpha t. So this is our u hat alpha t. Okay, next step number 4. Okay, inverse transform. Inverse Fourier transform. Okay, so we have uxt equals to inverse Fourier transform of u hat alpha t. So we have, by using the formula from the previous video, 1 over 2 pi, the integral of u hat alpha t e negative I alpha x d alpha from negative infinity to infinity. Okay, so you can substitute u alpha t with what we get from here. So 3 over 2 pi, the integral of 1 over alpha square sine 7 alpha sine 2 alpha t e negative I alpha x d alpha from negative infinity to infinity. Okay, e I alpha x here, we can transform it into cos alpha x plus, minus, since it's negative, minus I sine alpha x. So we can substitute e negative alpha x with cos alpha x minus I sine alpha x. So it becomes 3 over 2 pi. Okay, the integral from negative infinity to infinity, I alpha square sine 1 over alpha square sine 7 alpha sine 2 alpha t cos alpha x minus I sine alpha x d alpha. So we will get 3 over 2 pi. Okay. The integral from negative infinity to infinity, 1 over alpha square sine 7 alpha sine 2 alpha t cos alpha x d alpha minus I, the integral from negative infinity to infinity, 1 over alpha square sine 7 alpha sine 2 alpha t sine alpha x d alpha. Okay, from this integral, okay, sine we know is as odd function. Sine is odd function. The product of two odd functions is now become even. And cos we know as even function. So even multiply with even, so become even. But here we have sine is odd multiply with odd, so here it's become even. Okay, sine here also odd, so even multiply with odd is the product of this is odd. Okay, remember the integral of odd function equals to 0, so all this equals to 0. So meaning all this term equals to 0. But here we have even, so 3 over 2 pi. Okay, since it's even, we can consider in only positive part. So 0 to infinity, and here we have to multiply with 2. 1 over alpha square sine 7 alpha sine 2 alpha t cos alpha x d alpha. So 2 here we can cancel, so it's become 3 over pi, the integral from 0 to infinity, 1 over alpha square sine 7 alpha sine 2 alpha t cos alpha t d alpha. So this is our answer. So that's it. Thank you.